Hello everyone. In this session, let us discuss about the Perceptron training rule. This training rule we will be using in order to train the Perceptron to learn the weights. And this will work for linearly separable weights. Okay, so we already have seen what are linearly separable examples and which are not linearly separable. So in the earlier session, we have seen the implementation of and are, so which are linearly separable. So if you have not watched that video, please go back and watch that so that this is a continuation of that. Okay, so I will provide the iCard here in the description. You can just follow that. So now let us discuss about the Perceptron training rule. Okay, so what is this Perceptron training rule? So it is making the perceptron to learn the weight vector. So how we can make that is, we can modify the weights using this formula. Wi is equals to Wi plus delta Wi, where delta Wi is eta into t minus o multiplied with xi. So here what we are doing, already some weight is there. So to that weight, you are adding some small fraction of weight, delta Wi. So some small change in weight you are adding. Okay, so to calculate that, this is the formula. So here this symbol is termed as eta, which is called as learning rate. The value of eta will be usually very small. It will be between 0 to 1, and usually some small value only is preferred. So you can start with the value of 0.1, and from each iteration to iteration, this value can further be reduced also. So you can also take it as 0.01 or 0.005. So you can prefer some small value. So if the eta value is very small, we should go with number of iterations. So we just choose a moderate value. And here T is the actual output, which is also termed as the target output. T for target, which we are expecting, the actual one. O is the observed output. This is a calculated value. And Xi is the input. So here what does this I stand for? Suppose if I have two inputs, X1 and X2. So then for each input, I have to modify the weight. So if I take I value as 1, so this equation will become W1 is equals to W1 plus delta W1. And if I take I value as 2, so that will become W2 is equals to W2 plus delta W2. So like that, for each input, we have to modify the weight. So before doing that, first of all, let us see why the perceptron has to learn. What is the necessity for this learning? So this is the earlier example which we have already worked out, the implementation of the AND. Okay, I already mentioned since AND is a linearly separable one, I am taking the same example. Here weight I have taken as minus 0.2, W0, W1 I have taken as 0.3, W2 I have taken as 0.4. And if you substitute and if you compute Wixi, we are getting a value of minus 0.2. And if you are passing this through the activation function, we are getting a value of 0. So this is our observed output or the calculated output. So what is the target output? It is 0. So our network is able to compute what we are expecting. So these weights are successfully working with the given set of inputs. So I need not train my perceptron here in this particular scenario for these set of inputs. Next, let us take the next set of weights and the inputs. The weights are the same. Now the inputs are 0 and 1. So now let us compute Wixi. It is 0.2. And if you apply it to the activation function, since the value is greater than 0, I'm getting an output of 1. That means my observed output is 1. What is expected? Expected value is 0. So that means these weights are not working fine with these set of inputs. So our perceptron unit is not functioning as per our requirement. So what we should do? you should calculate the error. So error is always the difference between target minus observed. 0 minus 1, the value is minus 1. So since there is a mismatch in the target and the observed output, now there is a necessity to modify the weights. So we can modify the weights using the previous formula that we have seen, that is Wi is equals to Wi plus delta Wi. This is the formula we have seen, right? So now let's compute delta. So here x1 is anyhow 0. So we will modify W2. So in this I value, I'll just substitute 2. So I'm computing delta W2, which is equals to eta. So here let us take an eta value of 0.1. Okay, so eta is 0.1. And the error I already computed, T minus O, it is minus 1. And the input x2 value is 1. So which is giving me a value of minus 0.1. So now let us modify the weight W2. So it is W2 plus delta W2. So what is the value of W2? It is 0.4. Now the value of delta Wi is minus 0.1. So the new value that we are getting is 0.3. So we have modified W2. So now with this new set of inputs, if you want, you can also try with W1 also. So if you want to try with W1, delta W1 will be 0.1 multiplied with minus 1. Input value xi is 0. So this value will become 0. Then there will be no change in the W1. So W1 is 0.3 plus 0. So no change. W1 remains the same. W2 is modified as 0.3. So now let us check with these new weights whether our perceptron will work correctly and produce the target or not. Since we modified our weights, once again we have to start training the network again. So let us train our perceptron unit. Again, we are checking with the first set of inputs, that is x1 equals to 0 and x2 equals to 0. And if you compute sigma Wixi, it is minus 0.2 and the output we obtained as 0. Observed output is 0, target is 0. So with the new weights also, our perceptron is working fine with the inputs 0 and 0. Now let's check for the next set of inputs 0, 1. Whenever you modify the weights, you have to start the process again. Okay, so that means you just completed one epoch, and in the next epoch you start with the next set of weights. That means you completed one iteration, and in the next iteration these new set of weights should come into play. So now if you compute, sigma Wixi value is 0.1 and the output that you have obtained again is a 1. So which is varying from the target. So again I got an error value. So that means for these set of inputs also, our perceptron unit is not functioning according to the requirement. So what we should do, again we should try to modify. Let me change my link. Let's try to modify. So this time, once again we have to calculate delta Wi. So in the if you calculate delta W1, so it is eta value we have taken as 0.1. The same eta value we are taking multiplied with the error value T minus 4, that is minus 1, and multiplied with the input 0. So this is 0. So there will be no change in W1. It remains the same. 0.3 plus 0, which is 0.3. So now let's compute delta W2, which is eta value is 0.1, T minus O is minus 1, and the input value is 1. So we are getting a value of minus 0.1. So W2 value is 0.3 minus 0.1. which will give us a value of 0.2. So now, since our weights are modified, again we have to start the process from the first set of inputs. So now let us see whether our perceptron will work fine for these set of inputs or not. Now let's try with the modified weights. W1 is 0.3, W2 is 0.2, and the inputs are 0 and 0. And this time the output that we obtained is 0 and the target value is 0. So for this set of inputs, our perceptron is working fine. Nice. Now let's proceed with the next set of inputs. The next set of inputs are 0, 1. These are the modified weights. And now if you observe, the output value is 0. The observed output is 0 and the target is 0. So what will be the error? There is no error term. So that means our perceptron has learned to work with these set of inputs. Okay, so what are the weights that we obtained? 0.3 and 0.2. So for with the same weights, let us work with the next set of inputs. When we should stop this process is when these weights will work fine with all the set of inputs, then you can stop the process. That means our perceptron is trained enough with the desired weights. Otherwise, we need to keep on modifying the weights. So let us check with the next set of inputs, that is 1, 0. So with 1, 0, if you try, sigma WIXI we have obtained as 0.1 and the output is 1. What is the target output? Target output is 0. We are expecting for a 0, but we obtained a 1. So we have an error. So that means these weights are not suitable for this particular set of inputs. So what we have to do, again modify the weights. Let's modify. We have modified the weights. W1 is modified now. W2, since x2 value is 0, W2 remains the same. And with this, we are modifying the weights again. W2 is the same. It is 0.2 plus 0, it will be a value of 0.2 itself. So now since the weights are modified, once again we have to start the process. So we are entering into the next epoch or the next iteration. So again, we should start with 0, 0. So now these are our modified weights. W1 value is 0.2, W2 value is 0.2, and sigma WIXI is minus 0.2. Observed output is 0. Our target is also 0. Okay, fine. So these weights are working fine with the first set of inputs, that is 0, 0. Next, let's try for 0, 1. Okay, so with 0, 1, if you try, sigma WXI value is 0. Since the value is not greater than 0, the output is 0. So observed output is 0, the target is 0. So there is no error term. So our network is working fine with this set of inputs too. Next. Here, the next set of inputs are 1, 0. Target value is 0. The observed value. So we modified it. So 0.2, 0.2. So this becomes 0. So the output value is 0. So observed is 0. Target is also 0. So there is no error. So the error value is 0. So hence, with these set of inputs, our network is functioning fine. Our perceptron unit has learned the weights. So now let us try for the next set of inputs, that is 1, 1. So again, if you compute sigma WIXI, the value is 0.2 and the output that we have obtained is 1. So this is our observed output and the target is also 1. The target value. So both are matched. So for the set of inputs 1, 1. So finally, our network is working fine with these set of inputs. W1 is 0.2, W2 is also 0.2, and here W1 is 1. And if you apply it to the sine function, the output that we have obtained is a 1. So that means with these set of inputs, our perceptron unit is working correctly and it is giving us the desired result. There is no difference between the target and the observed. So that means our perceptron has learned the weights. So this is how the perceptron training rule works. So fine. And in this example, I have taken a standard eta value of 0.1. Suppose if you have taken a smaller value like 0.002, if you take, so it will take number of steps. Here we have just finished the process in just 3 epochs. If you take this value as 0.002, this might take number of epochs. So based on the time limitation and the training time that you have, so everything is dependent upon the training time. So if you take a smaller value of eta, the training time will be more. If you take a larger value of eta, the training time will be less. So this is how our perceptron training rule works. If you have any queries, do post in the comment section. And if you find this video helpful, please do share this to others. Do subscribe and like and also comment. So your comments will tell me how good my sessions are going on. Thanks a lot for watching. See you in next session.